So next, there's a special case of the mean value theorem called Rolle's theorem. Basically, this mathematician figured that this was significant enough to create a whole theorem based around this. We're not necessarily going to use this too often. We can really just use the mean value theorem for everything that we want to do. But I figure I probably should show you this. This is just a special case of the mean value theorem. And here's what it says. If, number one, we have a function that's continuous on a closed interval. If f of x is continuous on some closed interval from a to b, along with being differentiable on the open interval from a to b. Same requirements as our mean value theorem. But there's going to be a third requirement this time. If in addition to those two, f of a equals f of b. I have some function that's continuous on a continuous and differentiable on a closed interval from a to b, and f of a equals f of b. I'd like you to draw some continuous and differentiable functions starting here, ending there. I guarantee that no matter what you drew, as long as it was continuous and differentiable, somewhere that function is going to have a slope. A slope of what? Actually, think mean value theorem. What slope must be guaranteed? I think if I drew something like this, or whatever, doesn't really matter. What's the slope of my secant line? 0. Somewhere I have a tangent line with that same slope. Not the mean value theorem, Rolle's theorem guarantees that if we're continuous and differentiable and f of a equals f of b, then somewhere our derivative must equal 0. Then there exists a c value in the open interval from a to b such that f prime of c equals 0. Really just by our mean value theorem, f of b minus f of a is 0 over b minus a. We're going to get a slope of 0 by using the mean value theorem. Let me show you one or two examples of this. I want to determine if Rolle's theorem applies to f of x equals x squared minus 3x plus 3 on the closed interval from 1 to 2. If it does, we want to find the c value where f prime of c equals 0. Number one, is that function continuous on the closed interval? Sure it is, all polynomials are continuous. F of x is continuous on the interval from 1 to 2. Number two, find your derivative, and then tell me, is f of x differentiable? Well, my derivative is going to be 2x minus 3. Sure, that's continuous, so our original function f of x is differentiable. On the open interval from 1 to 2. Find f of 1. Find f of 2. And tell me if they're equal. f of 1 is going to equal 1 squared minus 3 times 1 plus 3. 1 minus 3 is negative 2, plus 3 is 1. F of 2, 2 squared minus 3 times 2 plus 3. 4 minus 6 is negative 2 plus 3 is 1. Yep. F of 1 equals f of 2. So Rolle's theorem applies. There exists a C value such that f prime of C equals 0. There's some place where the derivative equals 0. Where does that happen? I think you can figure that out. Where does the derivative equal 0? Let's see, I'm going to set my derivative equal to 0. I'm going to say 2x minus 3 equals 0. Add 3, 2x equals 3, x equals 3 halves. When x equals 3 halves, my slope's going to be 0. Go verify this quickly right now in Desmos. Things should work there. One more example, I think, that I want to show you. F of x equals the cosine of x on the interval from 0 to pi over 3. I want to try to prove that somewhere the derivative is going to equal 0 by Rolle's theorem. Is our function continuous? Sure, we know what cosine looks like. That's all good. F of x is continuous on that closed interval from 0 to pi over 3. Are we differentiable between 0 and pi over 3? Well, f prime of x, the derivative of the cosine of x, is the negative sine of x. Yeah, I know that there are no issues with that one, so f of x is differentiable on the open interval from 0 to pi over 3. Find f of 0. Find f of pi over 3. Let's make sure those are equal. Does f of 0 equal f of pi over 3? F of 0, cosine 0. Cosine of 0 is 1. F of pi over 3, cosine pi over 3. Cosine pi over 3 is a half. I don't think so. F of 0 does not equal f of pi over 3. Rolle's theorem doesn't apply. I cannot guarantee that somewhere the slope of the cosine of x between 0 and pi over 3 will equal 0. In the final video of this section, and really of this unit, we're going to take a look at a couple applications of this and see how this is tested on the AP exam and all that good stuff.